Alright, let's take a look at question number 1. In question number 1, we're being assessed on how to factor higher degree binomials. In this case, we're looking at a quartic binomial. The question is, the expression w to the fourth minus 36 is equivalent to. So the task is to factor this quartic binomial and see which of these factored states is equivalent to it. Before we get started with the factorization process, let's go ahead and review the formula that will guide the factoring process. So let's go over the formula. The formula that we are going to use is known as the difference of squares formula. Okay, difference of squares. Alright, so you might have seen this formula before being applied to lower degree binomials. You might have seen this formula, a square minus b square. Remember, you have to have a difference, a square minus b square. Now, if you want to factor this, all you do is you take the square roots of the first term and the last term, and you express the roots as a sum and difference. Okay? So if you square a square, you get a. If you square b square, you get b. So it's going to be a plus b times a minus b. Remember, when you're taking the square root or rooting, you're dividing the power by 2. Okay, that's basically what it is. Now we can extend this formula to any binomial, difference of binomials where the powers are even and the same. Check this out. What if we have a to the fourth minus b to the fourth? All we'll do is we square root these terms and express them as a sum and a difference. So if I square the first term, I get a square. If I square the second term, I get b square. So a square plus b square times a square minus b square. Let's extend it further. How about a to the sixth minus b to the sixth? This is a square also. How do we know that it is a square? Any even power term is a square. Why? A square is a term where the power is divisible by 2. Okay? So when we square these two, what we're going to be doing in essence is dividing their powers by 2. So we're going to have a to the third plus b to the third times a to the third minus b to the third. Alrighty? Okay, now let's go ahead and attack the problem, having written down the formulas that will guide our problem solving process. So what we're trying to do here is we are trying to factor w to the fourth minus 36. Now take a look at these three formulas right here. Which one do you think is applicable to this particular problem? It's the middle one, right? Because that's the situation where the first term is raised to the fourth power. Now what we're going to do, we're going to apply the difference of squares formula. We're just going to square root the first term, square root the last term, and express the roots as a sum and a difference. Now to make sure no one is lost in this process, let me pull out the terms and find their square roots independently. Okay, so if you have w to the fourth, we have, let me put the formulas on top here. We need, this is what we have here is a to the fourth minus b to the fourth. Okay, so just like this. Now we want to figure out what is a square and what is b square, so we write them as sum and differences. Okay, alright, so we have the first term is the a, right? So a to the fourth is w to the fourth. So to get what a is, we just simply root both sides, take the square root, and that will yield the result a square. Remember, when you root, you divide them by the power by 2. A square is going to be w square. Okay, so that's the result of rooting w to the fourth. And then we also have, what else do we have? We have 36 b to the fourth. So b to the fourth is 36, right? So b to the fourth is 36. Now what are we going to do here? We're going to square root, right? Using the difference of squares formula, we have to root the first and the last terms, root. So the square root of b to the fourth is just b, and is b squared, and the square root of 36 is 6. Now we're going to express this factored state as the sum and the difference of a square and b square. You notice what we have here. We have a square plus b square, and then a square minus b square. That is going to be the factored state. All right. So using that formula here, let's see what we'll have. Our final answer is going to be w square, which is a square plus b square. B square is 6 times a square again, which is w square, minus b square. B square is 6 again. Ladies and gentlemen, this is the equivalent form of the expression w to the fourth minus 36. All right, so the answer to question number 1 is option 4. So now you know how to do it. Let's go ahead and just verify to see if our selected answer is correct. Okay, you don't have to do this, but some individuals do not like to factor. So another way to do this problem is by expanding the options to see which one yields w to the fourth minus 36. So we're just going to pick the answer we selected because we know for certainty that this should work. All right, so this is just to check to show that our selection is in fact correct. So what I'm going to do is I'm going to expand this, and if I end up with the original problem, the original expression, then I know that my answer is in fact correct. We're multiplying two binomials, so we're going to double distribute. Just FOIL it out. First, outer, inner, last, just like a Punnett squares. Alright, so what do we have here? W squared times w squared is w to the fourth. Remember, when you're multiplying exponents with the same base, you add the powers. Okay, w squared times negative 6 is negative 6w squared. 6 times w squared, so we've done first outer. Now we're doing inner, is plus 6w squared. And then last, plus 6 times minus 6. When you multiply different signs, you always end up with negative, so negative 36. Now if you take a look at the center terms, they're opposites of each other, so they take each other out. And then our expanded form of this result we got here is w to the fourth. Let's try that again. W to the fourth minus 36. Now, is this answer the same as what we started with? It certainly is. So that shows for a certainty that our answer is correct. So what do you all think about this factorization problem? Do you think it was easy, medium, or difficult? Let us know by posting your response to this question in the comments.